Good morning, class. We are in the section of further mathematics for SS2 students. And the topic of today is differential calculus. I want to quickly recall our knowledge of differential calculus in the previous class when I considered the concept of differential calculus, what differential calculus is all about. And during the class, I let you know that the process of finding the derivative of function is what we call calculus. Today's class, I want to move forward to the concept of gradient of function. Because during the last class, I let you realize the concept of differential calculus and we discussed extensively about the concept of limit and the properties of limit. Today, we want to quickly look into the gradient of function. Let us quickly consider the diagram on the board. We have the graph of y is equals to f of x. And from the diagram, we observe a curve which moves from point A to point B. So from this, at point A, we have our coordinate value of x1 and y1. At point B, we have the coordinate value of x2 and y2. And at the gradient point C, we have x2, y2. I want us to quickly recall from our knowledge of coordinate geometry that we have considered in the time past. We realize that at this very point on the plane where we have 2 points A and B, we can easily find the gradient of point. And what do we call the gradient of point? The gradient of points, which we usually represented by m, simply means the increase in y value with the respect of x value. So, what does that mean? The increase in y value with respect to increase in x value is the same thing as m being equals to y2 minus y1 all over x2 minus x1. I believe we are following like this. I want you to quickly draw the diagram and write. From this point, we can easily get our increase in x. What will be the increase in x, class? Our increase in x is denoted as delta x, which is the same thing as x2 minus x1. From this relationship, class, we can easily get what our x1 value is or what our x2 value is. Are we getting it? From change in x to be x2 minus x1, we can get what our x2 is. What is x2? Our x2, which is the increment in x value. x2 is the same thing as delta x plus x1. Are we following now? From this point, we can easily recall from the function given to us. What is the function given to us? The function given to us is equals to y, which is equals to f of x. Y is equals to f of x. Y equals to f of x. So from the function given to us, we have y, which is equals to f of x. So we can say that y1 is equals to f of x1, isn't it? So, which is the same thing as y2 being equals to f of x2. Are we getting it? So, what is our x2? Is the same thing as f of x plus x1 plus delta x minus x1 . So at this point in time, we are trying to measure the rate of change. As x value is increasing, definitely we should expect a sort of increment in y value as well. Let us quickly check the relationship like that before I proceed forward. Or let me quickly digress to remove this. As my y1 is equals to x1, y2 is equals to x2. So as I'm trying to measure the increment in x, so definitely the increment in x should give me x1 plus delta x. Let me remove this so that it will give the clear picture of what we are trying to do. So at this point in time, I want you to quickly observe it and see that there is a relationship between all these variables. So as I'm trying to measure the gradient from the gradient m that I have here, my m is the same thing as y2 minus y1 all over x2 minus x1, which is the normal gradient that we have been observing before. So for us to continue from this end, and we know that our y1 is equals to f of x1, y2 is also equals to f of x2. So for us to utilize the gradient that we have here, our y2 is the same thing as f of x1 plus delta x. So if I slot it into the gradient that I have here, definitely my y2 will turn to f of x1 plus delta x, while my y1 will turn to f of x1. Am I communicating right there? And my x2 minus x1 is the same thing as my delta x that I have here. So I want to interchange the parameter and see what we can observe at the end of the day. So definitely my gradient, which is the rate of change, is the same thing as dy all over dx, which is the same thing as my y2 is the same thing as f of x1 plus delta x minus my y1, which is the same thing as my f of x, because my y1 is the same thing as f of x1. F of x1 all over, what is my y2 minus y1, which is rate of change of x, which is delta x. So this very value that I arrive at is what we call the gradient function. The value that I arrive at now is what we call the gradient function of y is equals to f of x. So from this, I want to continue with the gradient of the given function, or let me say derivative of a function. I will quickly clean this diagram and introduce the concept of derivative of function. So in the concept of derivative of function, we want to see what we can observe there. From the diagram now, I want to change the parameter here. Let this place be point P and let this place be point Q. So at this point P here, I have my x value, which is delta x. This place will give me delta x. So as the point A is increasing to point B, definitely we have the rate of change of this point with respect to this, which will give me I think we have x2 here and we have y2. Then this point, I have what we call f of x. Are we getting it? We have f of x, which is the same thing as y value. So on our y-axis, I have y plus delta y, and I have, at this point, I have x plus delta x. Of course, x is increasing. Then also my y is also increasing. We have y plus delta y. Y plus delta y here. So at this point in time, I have my rate of change here on the y-axis. Y will change, x will change as well. My f of x here, remember, is the same thing as the function, original function of y given to us. So at that point, we want to see what will happen. As I've explained earlier on, as the point is moving from this place to this place on the y-axis, I have y plus delta y here, and the whole here will give me the rate of change of y, which I call delta y. So from the gradient function, we can guess what we can obtain from there. Can we guess what we can obtain from there? From our y is equals to f of x. From y is equals to f of x. Of course, as y is increasing here, we see that our x value is also increasing, which gives rise to delta x here. So definitely this will give me x plus delta x. X is increasing, y is also increasing. So from this place, I can utilize what I obtained from the diagram here to say that y plus delta y is equals to x plus delta x. Are we following now? But initially, we are given all this, the function of x and that of y. Y is a function of x, of course. So we want to measure the rate of change that has happened between point P to Q. But remember, from the concept of our limiting value, we know that as this point P is moving, this point Q is moving towards point P, the rate of change will be decreasing as the gradient of the point is moving from point Q to point P, it will be reducing. It will get to a point that it will be closer to zero, but it is not exactly at zero. So we want to measure the rate of change that will occur from this point Q to P. As this point is moving closer to P, the rate of change will be reducing to the extent that it will tend to zero, but it's not exactly zero. So we want to measure that rate of change. Delta y will now give me x plus delta x minus the value of y. Y is the same thing as f of x. So we have it here. So for us to now measure the rate of change as the limiting value tends to zero, it's closer to zero, but it's not exactly zero. We have delta y we have our delta y all over delta x will be equals to x plus delta x minus f of x, everything over delta x. But remember, delta x tends to 0. So this very point is what we call the limiting value, which is the derivative of the function. So this is what we call the derivative of the given function f of x with respect to function, the derivative of function of f of y with respect to f of x, which we can call it dy all over dx, or we call it dy over dx, or f of x prime. Are we getting it? F of x prime. So as we are moving on this topic, we may likely come across all the terms that we are going to use. I call dy dx as dy all over dx, or f of y prime all over f prime x.